Okay, so when you look at the question we have, we are asked to evaluate the following: 25 on 64, all exponent half; 8 on 27, all exponent 2 on 3; 243 on 32, all exponent minus 1 on 5. So we are asked to evaluate the following, and this one is indices. And before we solve this question, let's look at the general idea of indices. We have laws of indices and we have properties of indices. Now, let us begin with the laws of indices. Okay. Now, from indices, the first law, if you have a exponent m times a exponent n, this is equal to, that is when you have numbers of variables of the same basis multiplying. According to indices, when you keep one of the base constants, the base is a and the exponent is m. Here the base is a, the exponent is n. And because the bases are the same, according to the first law of indices, when we keep one of the base constants, we add the exponent together, so we have m plus n. That is what the first law says. Okay, so if you have 2 exponent 3 times 2 exponent 2, this is the same as, you see that this is the base and this is the index or the exponent or the power. So we have 2 exponent 3 times 2 exponent 2, and because they have the same basis multiplying, according to the first law of indices, we keep one of the base constants and we add the exponent. The exponent here is 3, the exponent here is 2, so 3 plus 2 will give us 5, and 2 raised to the power 5 is 32. I hope you understand that. So that's the first law of indices. Now the second law says that if you have a exponent m divided by a exponent n, this should be equal to, when you keep one of the base constant, the base is a, here the base is a, so they have the same basis, but the sign is division. The exponent here is m, the exponent here is n, so you keep one of the base constants, then you subtract the exponent, so you have m minus n. Don't forget, with the first law, when you have two numbers of variables of the same basis multiplying, when you keep one of the base constants, you add the exponent together. But what is division? You keep one of the base constants, you subtract the exponent. Now, with the third law, we have a exponent m into bracket or exponent n. What the third law is saying is, if you have an indices in the bracket, you have a exponent m, a is the base and m is the exponent, or into bracket exponent n. What the third law is saying is, the m has the chance of multiplying the n, so this will be equal to a exponent m times n will be mn. That means that if you have 2 exponent 3 or exponent 2, from the first law, this is the same as 2 exponent 3 times 2 will give us 6. I hope you understand that. And this answer is supposed to give you 64. So that is what the first law, the second law, and the third law is talking about. Now, let's consider some properties before we evaluate this question. Let's consider some properties of indices, some basic properties. Now, we also know from indices that a raised to the power 0 equals 1, where a can be any number or a variable. So a raised to the power 0. So any number or any variable raised to power 0 is equal to 1. It's a property, you need to understand that. I will later prove to you why any number raised to the power 0 is equal to 1. Then you also have it that a raised to the power minus 1 is the same as 1 over a raised to the power 1. But because a raised to the power 1 is the same as a, then it means that this is the same as 1 over a. So a exponent minus 1 is equal to 1 over a. So in general, it means that a raised to the power minus n is the same as 1 over a raised to the power n. I hope you understand that. So 2 raised to the power minus 3 will be 1 over 2 raised to the power 3. Okay, it's a property. Take note. You also have it that if you have a over b or exponent n, this is equal to, here you have a fraction inside the bracket. The numerator is a and the denominator is b, all exponent n. What this property is saying is the n affect both the a and the b. So what is happening? If you want to take away the bracket, then it means that this should be a raised to the power n, or by b also raised to the power n. And I guess you understand that. So take note of that. Then we also have another property that says that if you have a over b, all exponents minus n, this is equal to, the difference between this and this, the fraction is a over b, but here the exponent is n, here the exponent is minus n. What this property is saying is, when you interchange the position of the numerator and the denominator, that is when the b goes up and the a comes down, immediately the negative n will change to positive n. And this is also a property. So these are the basic things you need to know as far as indices is concerned. So the laws of indices, when numbers or variables of the same basis are multiplying, when you keep one of the base constant, you add the exponent together. So when with the second law, when two numbers of the same basis or variable is dividing, you keep one of the base constant, then you subtract the exponent. These are the laws and the properties of indices that we have. So we are going to use this idea to solve this problem that we were given. And at the end of the day, you will understand what we are talking about. So these are the laws, okay? These are the properties. And as we solve questions, you will understand this better, okay? Now, our first question over there. So there, our first question, we have to evaluate. The first one is what? 25 over 64, all exponents half. Now, if you remember, there was a property. We need to understand. There is a property that says that if you have a over b exponent n, this is the same as a raised to the power n, or by b raised to the power n. I guess you remember this property. This means that 25 over 64, all exponent half, is the same as 25 raised to the power half, or divided by 64, also raised to the power half, because the exponent is affecting both the numerator and the denominator. Now, when you get here, you see any number raised to the power half is the square root of that number. So in simple term, you can say that this is the square root of 25 over the square root of 64. I hope you understand that. And so you realize that the square root of 25 is 5, and the square root of 64, you have 8. Now, it means that 25 over 64, all exponent half, is the same as 5 over 8. Now, there is something I want to show you here. From here, you can decide not to solve it this way. But let me show you something here. Here we have 25 exponent half, or divided by 64 exponent half. When you look at the exponent, the numerator is 1, the denominator is 2. The numerator is 1, the denominator is 2. Now, there is something we can do. The base is 25, the base here is 64. So, can we express 25 to have an exponent 2 to a particular base? Can we express 64 to have an exponent 2 to a particular base? Yes, we can do that. This will be equal to, because 5 raised to the power 5 exponent 2 is the same as 25. Don't forget that exponent is half. Or by 8 exponent 2 is also equal to 64, or exponent half. Now, if you remember, the third law says that if you have a exponent m or exponent n, this is the same as a exponent m times n, and that is a exponent mn. It means that we can multiply 2 by the half, and in doing that, we have 5. 2 times half is 1, so 5 exponent 1, or by 2 times half is also 1, so we have 8 exponent 1, and 5 raised to the power 1 is 5, over 8 raised to the power 1 is 8. So the answer is still 5 over 8, and it's the same as this. And you need to understand this approach, because it's not all the cases that the exponent will be half for you to take the square root of them to make it simple this way. But in all cases, if you understand this way, it will be easy for you to simplify such questions or expressions. So let's see how best we can solve the second question. The second one, 8 over 27 exponent 2 over 3. So from the property, you know that this is the same as 8 exponent 2 over 3, or by 27 exponents 2 over 3. That means that the exponent is affecting both the numerator and the denominator. And so, can we also, now when you look at the exponent, you have 2 over 3. The numerator is 2, denominator is 3, numerator is 2, denominator is 3. So can we express 8 to have an exponent which is equal to the denominator of the fraction? This is what you have to understand. The denominator is 3. The denominator is 3. So consider that now. 8 can be expressed as 2 raised to the power 3. Already we have 2 over 3 outside the bracket. Then 27 can also be expressed as 3 raised to the power 3. Already you have 2 over 3. Why are you doing this? You see, we are expressing this in this form so that the exponent to the base in the bracket will be equal to the denominator of the exponent outside the bracket, so that our 3 can cancel 3 here, our 3 can cancel 3 here, and we are left with 2 exponent 2 all by 3 exponent 2, and 2 exponent 2 is 4, and 3 square is 9. That means that the question, that is 8 over 27 exponent 2 over 3 is equal to 4 over 9. This is the answer. I hope you understand that. Now I give this to you as an example. 243 all divided by 32 exponent minus half. Now with this one, we have a property that says that when you interchange the position of the numerator and the denominator, quickly the negative exponent will change to positive. So this is the same as 32 up here divided by 243 down here. Then quickly this will change to 1 over 5. Then you use the same approach as we did in the first question to solve that, and you also get the answer. So try that as an example. Let me know in the comment section what you have by solving 243 over 32 all exponent minus 1 and 5. God bless you. Follow